Morning. So this is the first meeting of the, not really a class, numerics class that's going on. The course Canvas last night, I uploaded a bunch of videos from when I was teaching this at my previous university. So there should be 8 actual recorded lectures already, which I noticed also included like the introductory topics that are in there. So I'm going to kind of lightly cover them because there's already some 40, 50-minute lectures on some of these topics, like backward air and things. So I'm going to try to give a kind of a big overview of what's going on and then talk about one of the fun areas that's going on, which has to do with zero finding, which is kind of one of our big topics as it's going in. But before I do that, I want to talk a little bit about the mechanics of this not a course. So there is a course Canvas. There are homework assignments that have been put up there, and I took a student who was in that class made a LaTeX document of what the homeworks were, and so I have those, so I made it into a PDF and uploaded those from when that course was taken. I promise not to grade a single one of these. This is not really a course. So my purpose is that you're going to try to do the homeworks, and you're going to attempt to prove them, and if you prove them or get the correct answer or whatever, great. You know you got the right answer. If you don't get the right answer, then you should come talk to me. There should be no embarrassment. I'm not expecting you to know this. I'm expecting you to run into some issues. But to save time, I don't want to go hunting for problems when there are no problems. This allows me to do my research over the summer. But if you run into an issue, by all means, come by, shoot me an email. For those who are going to watch this, hopefully this video is okay. This is on my cell phone right now. For those of you who are, watch on those, shoot me an email, or I put up discussion boards inside the course Canvas, so you could talk to each other. You could, this is one of those few times, post solutions to each other, but don't look at other people's solutions until you've tried to solve them yourself. It'll remove all the benefit. You're only going to get usefulness out of this if you try first, and then you can look at it. But try to get what the answer is that's going on and convince yourself it's true, because in real life, nobody's going to give you the answer because they don't know either. If it's any problem that's worthwhile, people don't know what the answer is. And if we do know what it is, then pull off regular routines and stuff. My philosophy, particularly in this course, is going to be one of which I want you to build everything on your own. Once you've built up those foundations, you can, of course, use the tools that are out there. But I want you to know how all those things work. So we're going to start from a very low level and build up those areas so you get used to how to write the software, how these things are going to perform, what the algorithms mean, how to implement the algorithms, things of that sort, which will then form a basis for when you go into the course in the fall, which will talk more heavily about, large sparse systems and odd areas and ill conditioning. If you've spent that time learning how these work, then you'll be able to get the benefit off of those. You will notice the videos that are currently on the website are of an extremely unique production quality. They were done on a handheld camera that I had at home on a tripod. I just aimed at the floor and had a piece of paper and wrote on it with markers. That was going on. The handwriting is horrible because it's mine, but it does cover all the information, and I'm sure the quality of the information is good even if the production value is low. You are welcome to make better versions of whatever you want that's going in there. If you want to, there are labs also that are in there. I believe it's 10 different labs, which were the labs I did in the course. You're welcome to write up solutions for those labs and whatever. The likelihood of me teaching these anytime in the future is, other than in this type of format, is very low. So I want to just make this something that's kind of a do-it-yourself course. It's kind of the goal. What's going on here? So, if you make particularly good solutions and want to contribute them for later people to be able to bounce off, then that's awesome. That's kind of where this one is going on. So I would take that opportunity. There is, if you want to get access to it, I do have a GitHub repo which has all the documents on it, including the labs, the LaTeX underlying files, and things of that sort, including labs from other time periods. That's going on.